0547, a tree line west of Toretsk, in Donetsk Oblast. A Russian tank company, 11 T-80 BVM main battle tanks, supported by 2 BMP-3 infantry fighting vehicles and a pair of Boris-Oglebsk II electronic warfare trucks, rolls out of a staging area and pushes west along a muddy farm track. The column is moving fast by Russian standards. Commanders on this axis have been sitting on this line for 6 weeks. This morning they got the order to advance. Above the tree line, nothing visible. No Ukrainian aircraft, no loitering munitions circling. The column's electronic warfare operators confirm the spectrum is clean. The Boris-Oglebsk II trucks power up their jamming arrays, blanketing the frequency bands that Ukrainian FPV drones depend on. The tank crews feel the protection. The column accelerates. What they don't know, the Ukrainian drone team that mapped this road has been awake for 48 hours, and they've been waiting for exactly this moment. Retention. Checkpoint. Checkpoint 030 Hook Resolution Tease. Here's what this engagement reveals about the war in late 2025 and into 2026. A $400 fiber optic FPV drone just made a $3 million tank company's electronic warfare coverage irrelevant. Not by jamming it back, not by outspending it, by going around it, literally, and striking from the one quadrant the Boris-Oglebsk II's antenna arrays cannot cover. This is how Ukrainian drone operators have been dismantling Russian armored advances west of Toretsk since autumn 2025. And this engagement, reconstructed from OSINT-confirmed drone footage and open-source tracking data, is the clearest example yet. By late 2025, the Toretsk axis in central Donetsk Oblast had become one of the most contested stretches of the front. Russian forces had pushed into the town through summer and autumn, grinding through industrial districts block by block. Ukrainian defenders traded space for attrition, pulling back to prepared positions on the western outskirts, while drone teams worked the approach roads relentlessly. Open-source analysts tracking the sector noted a shift in Russian tactics through October and November. Armored columns began moving with dedicated electronic warfare coverage, specifically the Boris-Oglebsk II, a truck-mounted platform designed to suppress drone communications across a broad frequency range. The logic was simple. Jam the signal, the drone falls. No drone, no ambush. The Boris-Oglebsk II is not trivial hardware. Russian military publications describe it as capable of suppressing communications and navigation systems across multiple frequency bands simultaneously, with an effective radius that, in optimal conditions, can extend several kilometers. Against a standard radio frequency FPV drone, the kind Ukrainian operators had been using at scale since 2023, it works. Ukrainian drone teams confirmed as much. Hits dropped. Drones lost signal and fell before reaching targets. The system was creating what Russian planners believed was a protected bubble around advancing columns. The problem is geometry. Retention. Checkpoint. 4 o'clock stakes bend. A jamming bubble is not a sphere. It is shaped by the physical placement of antennas on the trucks, by terrain, by the direction the trucks are facing, relative to the column's axis of advance. The Boris-Oglebsk II is most effective in the forward arc and the flanks. The rear quadrant, directly behind the jammer's primary antenna orientation, especially when the trucks are moving and the arrays are optimized for forward coverage, is the system's weakest point. Ukrainian drone operators identified this vulnerability through methodical recon, not through intelligence leaks, through Mavic reconnaissance drones, flying at high altitude at the edge of jamming range, systematically probing the bubble's boundaries over multiple nights. This is the part of the story that never makes the headline footage, but explains everything that follows. For 48 hours before the columns advance, a Ukrainian FPV team, OSINT analysts reviewing footage estimated between 4 and 6 operators, flew Mavic 3 reconnaissance drones along the approach routes west of Toretsk, logging exactly where their video feeds degraded and where they held. They were building a map of the Boris-Oglebsk II's effective coverage area, not theoretically, but empirically, flight by flight, noting GPS coordinates where signal began to compress. What they found confirmed what Ukrainian drone warfare specialists had been circulating in internal channels since at least mid-2025. The rear quarter blind spot was real, consistent, and exploitable. The team also found something critical about the terrain. The farm track the Russian column used for its morning advance passed through a gap in a tree line approximately 800 meters west of the staging area. At that gap, the column would bunch. The lead vehicles would slow to navigate the break in the tree line. The EW trucks, positioned mid-column for force protection, would be momentarily oriented forward, their strongest jamming arcs facing west, away from the approach vector the Ukrainian team had selected. The team selected their firing position, a ditch line to the northwest, approximately 600 meters from the gap, outside the calculated jamming radius on the rear quarter. They pre-staged their fiber optic FPVs the night before. The fiber optic component is the key detail. Unlike radio frequency FPVs that rely on a wireless signal link between drone and operator, the link the Borisogledsk 2 targets, fiber optic FPVs trail a thin spool of optical cable behind them as they fly. The signal travels through the cable, not through the air. There is no radio frequency to jam. A single spool carries enough cable for approximately 1.5 to 2 kilometers of flight. The drones fly slower than their RF counterparts. The cable adds drag and limits maneuverability at the extremes, but within 600 meters, they are fast enough. The warhead on each is a standard RPG-7 grenade, repurposed as a shaped charge munition. Against a T-80 BVM, it will not always achieve a kill through frontal armor. Against the top deck, the engine compartment, the thinner rear plate, it is sufficient. The column rolls into the gap at 0547. What's most surprising about this engagement isn't that Ukrainian operators defeated the jamming. It's how precisely they had gamed the geometry of the Russian defensive system before a single drone launched. The lead T-80 BVM clears the tree line gap and pushes west. The second tank follows. The column is bunching exactly as the Ukrainian team projected. The EW trucks are mid-column, their arrays oriented forward. The rear quarter blind spot opens behind them. The first fiber optic FPV launches from the ditch line to the northwest at 0549. It carries no radio signal. The Borisogledsk 2 has nothing to jam. The drone crosses 400 meters in under 20 seconds and impacts the third tank in the column, a T-80 BVM, on the left side engine deck. OSINT-confirmed footage shows a flash and immediate smoke from the engine compartment. The tank does not explode immediately. It stops. It begins to burn. The column halts. Retention, checkpoint, 50% mid-roll hook. This is the moment that separates a well-executed ambush from a catastrophic loss. A halted column, vehicles packed close, unable to maneuver, commanders on radio trying to assess, is the worst possible configuration under drone attack. It is the scenario Ukrainian FPV doctrine has been optimizing for since 2024. The Ukrainian team launches the second drone before the column has processed what hit it. The second fiber optic FPV targets the rearmost T-80 BVM. The last vehicle in the column stopped just inside the tree line gap. The footage shows the drone approaching from a shallow angle, slightly above the rear deck. The impact is on the engine compartment. Second tank, stopped, burning. The column is now bracketed, one vehicle burning at the front of the kill zone, one at the rear. The remaining vehicles cannot easily reverse or advance without passing close to burning armor. Put yourself in the position of the Russian column commander at this moment. You have two tanks burning. You don't know the attack vector. Your EW operators are telling you the spectrum is still clean. Their systems show no active drone frequencies being transmitted. They're correct. There are no radio frequencies to detect. The attack is coming through a cable. You don't have a sensor for that. The Russian response, visible in footage reviewed by open-source analysts, is the standard one. Tanks break formation and push off the track into adjacent fields, attempting to disperse. This is correct doctrine. Dispersion reduces target density, but the fields west of the tree line gap, in late autumn, are soft. Two vehicles bog down almost immediately. They become stationary targets. The Ukrainian team launches two more fiber optic FPVs in rapid succession. The third drone targets one of the bogged vehicles, a BMP-3 infantry fighting vehicle that is pushed into the field to the south. The impact is on the top deck. The BMP-3 stops moving. A fourth drone is launched toward the second Borisogledsk 2 EW truck, which has pulled off the track and is stationary approximately 200 meters east of the burning lead tank. Here's where the operations logic becomes explicit. The EW truck is not an armored fighting vehicle. Its protection is thin. The fiber optic FPV impacts near the cab. OSINT footage shows the truck subsequently immobile. Whether the system itself is destroyed or merely disabled, the effect is the same. The jamming bubble collapses, and the moment it collapses, the Ukrainian team's radio frequency FPV assets, held back precisely for this, become active. This is the tactical sequence that Ukrainian drone specialists have been refining since late 2025. Use fiber optic FPVs to create the initial disruption and, critically, to neutralize the EW assets. Then transition to radio frequency FPVs, faster, more maneuverable, easier to control, with a standard goggle and controller setup for follow-on strikes against the now unprotected, disorganized surviving vehicles. Retention. Checkpoint of 68% subscribe. Subscribe to Silent Echo. We break down a new frontline engagement every week, tracking exactly how this kind of tactical evolution is reshaping the war in real time. The follow-on RF FPV wave, estimated by OSINT analysts at between 8 and 12 drones based on footage timestamps, begins approximately 4 minutes after the Boris-Oglebsk 2 truck is struck. The surviving T-80 BVM tanks, now dispersed across the field and the track, are engaged individually. Not all strikes are successful. Open-source footage from the engagement shows at least 2 RF FPVs losing signal and falling before reaching targets. The jamming from the surviving EW truck may still have been partially operational, or terrain interference caused dropouts. Ukrainian drone warfare involves real losses. This is not a clean sweep with a perfect hit rate, but the math is not close. OSINT analysts reviewing footage and geolocation data from this axis in the following weeks estimate between 5 and 7 T-80 BVM tanks from this specific company were confirmed destroyed or rendered non-mission capable in this engagement. Open-source tracking by analysts monitoring the Toretsk sector cross-referenced vehicle markings visible in drone footage with entries in Oryx's ongoing equipment loss database. Ukraine's general staff, in its reporting from this period, referenced armored vehicle losses on the Toretsk axis consistent with multiple company-level engagements. The numbers carry caveats. BDA from drone footage is imprecise. Vehicles can be disabled rather than destroyed, and some footage is geographically unverified. But 5 to 7 T-80 BVM tanks out of an 11-tank company represents between 45 and 64% attrition from a single engagement in under 15 minutes. One vehicle, a T-80 BVM, toward the western edge of the dispersed column, made it back. Footage shows it reversing eastward at speed, abandoning the other vehicles. Why it was spared matters. It was farthest from the initial kill zone, had dispersed to the northwest rather than south, and was partially obscured by a wood line that interrupted drone approach angles. It also happened to be in the quadrant where partial Boris-Oglebsk 2 jamming coverage was still effective. The surviving crew got lucky with geometry. That is what survival looked like on this axis in late 2025. The total cost of this Ukrainian operation, estimated from equipment visible in footage, Mavic 3 reconnaissance drones, fiber optic FPV frames, RF FPV follow-on assets, runs somewhere between $15,000 and $30,000, including reconnaissance time and operator costs in any reasonable estimate, against confirmed losses that, at replacement cost for T-80 BVM tanks, Oryx and Western analysts estimate Russian armored vehicle production and refurbishment costs in the range of $2 to $4 million per unit for modern variants, represent somewhere between $10 and $28 million in destroyed or severely damaged Russian equipment. The exchange ratio is not a rounding error. Here's a take that may generate some pushback. The Boris-Oglebsk 2 deployment on this axis was not an intelligence failure or a maintenance failure. It was a doctrinal failure. Russian planners understood what Ukrainian FPV teams were doing in 2024. They had a system that worked against the threat as they understood it. What they did not do, what the institutional structure of the Russian military has repeatedly failed to do throughout this war, is war game, the adversary's adaptation, before fielding the countermeasure. Ukrainian operators were testing fiber optic FPVs against Russian EW systems throughout the second half of 2024. Russian doctrine did not update fast enough. The Boris-Oglebsk 2 was a correct answer to the 2023 threat. By late 2025, it was fighting the previous war. If you track this war seriously, you already see this pattern. Every Russian countermeasure creates the conditions for its own defeat. Armor concentration drew HIMARS. Trench networks drew FPV swarms. EW coverage drew fiber optic workarounds. The adaptation cycle has been running faster on the Ukrainian side for 3 years. Retention, checkpoint, of 85% identity. Here's a question worth leaving in the comments. Is there a Russian countermeasure to the fiber optic FPV that doesn't require physically intercepting the cable? And if so, what does it look like? We don't have a clean answer. That's not a deflection. The physics of a hardwired signal genuinely limit what RF-based countermeasures can accomplish. What this engagement teaches, from a doctrine perspective, is something military analysts have been noting with increasing urgency: the industrialization of precision. Ukrainian FPVs are not precision munitions in the traditional sense. Their accuracy depends on operator skill, lighting, terrain. But at a cost of $400 to $700 per airframe, Ukraine does not need each one to be precise. It needs enough of them, launched from the right geometry, against a target that cannot maneuver. The Toretsk engagement provided all three conditions because Ukrainian operators spent 48 hours creating them. The column did not walk into an ambush by accident. It walked into a carefully mapped, geometrically exploited, sequenced ambush that was specifically designed to defeat the countermeasure the column thought was protecting it. That distinction, between a lucky drone strike and a systematic targeting process, is what separates tactical success from strategic effect. Oryx's tracking database, which relies on OSINT-confirmed photographic and video evidence of equipment losses, counted over 3,800 Russian tanks and armored fighting vehicles destroyed, damaged, abandoned, or captured as of mid-2026 since the full-scale invasion began in February 2022. That number represents years of accumulated attrition across every axis. What the Toretsk engagement represents is the acceleration, the same attrition, compressed into minutes, for tens of thousands of dollars rather than millions. The surviving T-80 BVM returned to the staging area east of the tree line. The crew reported the attack. Russian forces on this axis did not mount another armored advance in the following 72 hours, according to Ukrainian General Staff reporting from this period. Defensive positions were consolidated. The ground the column was supposed to seize remained Ukrainian-held. The burned hulks stayed where they stopped. Drone footage from subsequent days shows them still in the field, some still smoking. The Boris-Oglepsk 2 truck is visible at the edge of the kill zone. Cab destroyed, antenna array collapsed. It will not be jamming anything. There's a detail from this engagement that's hard to get past. The Ukrainian team knew, going into that night of reconnaissance, that they were not guaranteed to get the geometry right. Fiber optic cable spools can snag on terrain. The blind spot they mapped could have shifted if the EW trucks repositioned. The column could have taken a different route. They built a targeting solution on a probability assessment, not a certainty. And when the column moved exactly as projected, that preparation paid off at a ratio that no armored doctrine from the 20th century could have predicted. Retention. Checkpoint. Last 60s payoff plus open loop. The debate in Western defense analysis circles through late 2025 and into 2026, has been about whether Ukrainian drone warfare represents a genuine doctrinal revolution or an asymmetric tactic that will be countered at scale once Russian production and EW adaptation catch up. The Toretsk engagement, and dozens of similar ones documented across the front in this period, suggests the question may be framed wrong. Ukrainian operators are not relying on a single tactic. They are running a continuous adaptation cycle. FPV, then fiber optic FPV, then sequenced multi-wave attacks, each designed around the current Russian countermeasure. The countermeasure informs the next adaptation. The cycle does not stop when one technology is defeated. It accelerates. What does that mean for the next 6 months on the Donetsk front? We'll be covering exactly that. Drop a comment with yes or no. Do you think Russian forces field a workable countermeasure to fiber optic FPV drones before the end of 2026? The geometry problem is real. The answer is not obvious. We read every one. And if you want to understand how this same targeting logic is being applied to Russian command posts and logistics nodes further behind the line, that's the next breakdown.